Hey everybody, welcome to topic number 5. In this lecture video, let's review factoring polynomials. So, the following factoring of polynomials are the types of polynomial that we will encounter throughout this semester. So the very first one is called factoring the greatest common factor. Okay, so there are different ways we can find the greatest common factor. So normally to find the greatest common factor, we can use what we so called the prime factorization to break down the terms, okay, and count all the repeated factors. So I'm gonna just write one of these here on the side, for example. But normally students find the greatest common factor just by knowing the timetable. So what is the greatest common factor between 2, 22, and 10? So to break it down, 2 is 1 times 2. So I'm just going to use prime numbers here. Just write a 2. 22, if I break it down using prime number, gotta be 2 times 11. 10 is 2 times 5. So the greatest common factor between 2, 22, and 10 by counting the repeated factors. So the factor 2 repeated between all three terms, we will count that one time. Then that will be my greatest common factor between these three numbers. All right. Here I wrote for the variable, choose the smallest exponent. Why is that? Well, the first term is 2x squared y to the third, right? X squared. X squared means x times x. The next term, 22x squared. X squared means x times x again. The third term, 10x to the third, right? X to the third is x times x times x. So if I count the repeated factor between the three terms, one side of x is repeated, count that one time. Another side of x is repeated, count that one time. So 2 times x, of course, is 2x squared. So that should be my greatest common factor. The variable y did not repeat between all three terms because the second term and the third term is y to the 0 power. So the smallest exponent is y to the 0 power, which is 1, right? If you don't see it, that means it's to the 0 power. Okay, so my greatest common factor is 2x squared. Factoring is a division, okay? So without writing everything out, okay, I'm just gonna say it, as I divide. So we factor out the greatest common factor first, then we write open parenthesis, and what's left over for the three terms will go inside the parenthesis. 2 going to 2 one time. Factoring out the x squared to the outside, no x left. So what I'm doing here is the greatest common factor is 2x squared will go into 2x squared y to the third so many times. So this is the work that I'm actually not writing out. 2 and 2 cancels out, x squared cancels out. So that's why the answer here is y to the third. So that's what's left over in the parenthesis. So 2 going to 2 one time, both factor out both of these x squared to the outside, no x left. So the only thing left for the first term should be y to the third. 2 going to positive 22, positive 11 times, factor out both of these x, no variable left for the 11. 2 going to positive 10, positive 5 times. Factoring out 2 x's from 3, right? Taking away 2 out of the 3, 1 x is left. There you go. All right, so I know I factored completely because the way to check for your answer after you factor is to check inside the parentheses, see if anything can be factored out. So there's really nothing can be factored out between y to the third, positive 11, and positive 5x. So I know this is factoring completely. Okay, let's try another one. Okay, greatest common factor between 645 and 21. You can break it down like I did up here, or if you know your timetable pretty well, you know 3 is inside all three of these terms, right? 3 can go into 6, 3 can go into 45, 3 can go into 21. For the x, variable x repeated between all three terms. The smallest exponent is third power, so that's why they can factor out. The variable y repeated between all three terms. Smallest exponent is y to the first, so that I can factor that out. So this is my greatest common factor. So once I write it down, once I wrote it down, I write times open parenthesis. Okay, this is all multiplication. Your final answer is all multiplying. Okay, let's divide. 3 going to 6 2 times. Factor out both of these. Factor all three of these x to the outside. No x left. Factor out 1y to the outside. From 3 of them, y squared is left. 3 going to positive 45, positive 15 times. Factoring out 3x's from 4, 1x left. Take away 1y from 2, 1y is left. 3 going to negative 21, negative 7 times. Factoring out all three of these x to the outside, no x left. Factoring out the only y to the outside, no y left for my negative 7. There you go. That's your answer. So the very first type of factoring problem is factoring out the greatest common factor. Every factoring problem, this is the first thing that we look for, okay, is look for the greatest common factor. Another type of factoring problem we're going to encounter is called factoring by grouping. Factoring by grouping is a very particular type of factoring problem. It requires us to factor twice. It has two main characteristics. That's how you spot factoring by grouping problem. You got to have 4 unlike terms, first of all, and there can be no greatest common factor between these 4 terms. Okay, then that trigger, once you can spot that, then this is a type of, this is a factoring by, this can be a factoring by grouping problem. Okay, so what are the steps on how to factor in these type of problem? Well, we're gonna group the first 2 terms and the last 2 terms by underline them. Then we're gonna factor the greatest common factor between the first 2 terms, right? And then factor out the greatest common factor between the last 2 terms. Every time I factor out the greatest common factor, I will actually have a parenthesis with whatever is left over inside of it. So then once we've done that, now there should be only 2 terms left. And what's inside the parenthesis should match. So once they match, that becomes the what? The greatest common factor, because you got 2 terms, and what's the same thing between the 2 terms is the matching part of what's inside the parentheses, so we can factor again. Okay, so for example, you got 4 unlike terms here, no greatest common factor. So I'm gonna group the first 2 terms by underline them, and then group the last 2 terms by underline them. All right, so that's number 1 and 2. Factor out the greatest common factor between the first 2. So between 6 and 15, I can factor out a 3. Between x to the third x squared, I can factor out x squared, right? The smallest exponent. Then I write open parenthesis. Let's divide. 3 going to 6 2 times. Factoring out 2 x's from 3 of them, 1 x is left. 3 going to positive 15, positive 5 times. Factoring out both of these x's, no x left. Okay, so that's factoring out the greatest common factor between the first 2 terms. All right, factoring out the greatest common factor between the last 2 terms. Well, what can I factor out between negative 2x and negative 5, where the 2 parentheses, what's inside the 2 parentheses, will match? Well, if you think about it, between negative 2x and negative 5, the common factor is a 1. Okay. However, if I factor out a positive 1 going to negative 2x times. Positive 1 going to negative 5 is negative 5. So if I factor out a positive 1, the 2 parentheses does not match. So that means I have to factor out a negative 1, because negative 1 will go into negative 2x, positive 2x times. Negative 1 going to negative 5 is positive 5 times. That's how I get the 2 parentheses to match. So step number 4, with this subtraction sign outside the parentheses, I got 2 terms. Okay, so this is my first term. This is my second term. What's the same between the 2 terms are the 2x plus 5. So the 2x plus 5 is now my greatest common factor. Is 2 terms representing 1 greatest common factor. So I got to put that in the parenthesis. So if I factor out the 2x plus 5, what should be left over for the 2 terms? If I take out the 2x, factor out the 2x plus 5, my red term, only thing left is 3x plus 2. Excuse me, 3x squared. If I factor out the 2x plus 5 from the second term in purple, then the negative 1 is left. There you go. That will be my answer. Okay, let's try again. For unlike terms, no greatest common factor between the four terms. So I'm gonna group the first two and then group the last two. So a lot of times when the grouping, so when we group first two and last two, and it somehow doesn't work out where the two parentheses cannot match, I can group the first and the third, second and the fourth. Okay, I can group it differently. All right, factor out the greatest common factor between the first two and the last two. So between 20 and 55, I can factor out a 5. Between m to the third m squared, I can factor out m squared because that's the smallest exponent. Let's see what's left. 5 going to 24 times, factor out 2m from 3 of them, 1 is left. 5 going to negative 55. I still made a mistake here. I meant to change this. This is supposed to be a plus sign here. My apology. I still forgot to change that. I will try to change that in the handouts. Let me open up the handout before I forget. Hang on 1 second. Let me find it. There we go. Fixed it. All right. So again, 5 going to negative 55, negative 11 times. I factor out both of the m to the outside, no m left. So now, just like the previous example, between the negative 4 and positive 11, I have to factor out a negative 1 because that's the only way I can make the two parentheses to match. Negative 1 going to negative 4m is positive 4m. Negative 1 going to positive 11 is negative 11 times. So with the subtraction sign here outside the parenthesis, now they give me two terms, and what's the same about the two term is the 4m minus 11. So common factors are the factor that are common are the same factor in every terms. So since my 4m minus 11, this factor is in both terms, so that becomes my greatest common factor. Since I got two terms representing one thing, always put them in a parenthesis. So what should be left for the first term in red, once I factor out 4m minus 11 is 5m squared. Second term, negative 1 should be what's left. There you go. All right, so that's factoring by grouping. So we will do this quite a bit throughout the semester. The next one is factoring trinomial. So as you can recall from the previous topic, we say that a true trinomial is the last three terms of a polynomial with an exponent that says 2 power, 1 power, no power. So the trinomial has a standard form of ax squared plus bx plus c. There are two ways we factor in trinomials, okay? One of them is called trial by error methods. So the technique I'm going to show you is called trial by error, which is another way of saying we're gonna do FOIL methods backwards, okay? So keep in mind, there are 5 steps we're gonna take. I'm not gonna read through all this. I'm gonna just say it as I'm doing the problem, okay? Every example I'm going to do for factoring trinomial in this class is where the first term, the x squared term, is always going to be positive. Otherwise, the way how we do the signs doesn't quite work. Okay, so again, first thing, factoring out the greatest common factor if there is one. If there is, factor out the greatest common factor and write what's left inside the parenthesis. Then we will write two open parentheses, okay? If we don't have a greatest common factor, we're just simply gonna write two open parentheses. Then the next step is finding all the factor of the first term and the last term. So here we go. Let me do an example for you, okay? Between 5, 7, 6, there's no greatest common factor. So I will end up writing two parentheses right away. So I'm gonna jump down to number 3. Okay, I'm gonna color code this. All right. Number 2 on my steps is find all the factors of the first term and the last term. First term is 5. The factor of 5 is only 1 times 5. Find all the factors of the last term. 6. The factors of 6 started with 1. 1 times 6. The next one is 2 times 3. The one after 2 times 3 should be 3 times 2, which I already got the same number as I done before. So that should be the end of it. So step number 3 says from the correct answer number 1 and 2, starting with the last set of factor, 2 factors that are closest in numerical value, write the factor you just found inside the 2 parentheses accordingly. The factors of the first term go at the beginning of the 2 parentheses. So I'm doing the FOIL method backwards, right? So first term is 5. So the factor of 5 should go at the beginning of the 2 parentheses. The factor of the last term, okay, should go on the back side of the 2 parentheses, 2 and 3. Okay, now I'm gonna demonstrate how we can do the inner and outer combined to give me my middle term. So remember from before, let me see if I can find this real quick. Back in topic number 4, when we do the FOIL methods, we say that this middle term comes from the inner and outer combined, right? So now it's basically what we're doing right now. Okay, so outer, 2 outside number multiplied together. 1 times 3, right? 1 times 3 is 3. Inner, 2 times 5 is 10. Can 3 and 10 combine somehow give me my middle term, which is positive 7? Yes, it can, right? It can. But how? Let me scroll back up. How is subtract, right? 10 and 3 subtract. So let's do the signs. So once I know my in and outer will give me my middle term, then I can look at step number 5. How to assign signs. If the last in the trinomial is positive, that's not what I got. I got negative. So part B, if the last term of the trinomial is negative, it means the inner and the outer must subtract to get to the middle term. And the choice for the signs inside the 2 parentheses should be a positive and a negative. So it all depends on the middle term. Okay, the key here, it depends on the middle term. So when this last sign, when the last term is a negative, that means the inner and outer got to subtract to get to my 7 in the middle. The 2 signs in the parentheses, 1 positive, 1 negative. So it all depends on the middle term. Since my middle term is a positive 7, that means I need to give this positive to the bigger of the 2 inner and outer, because I need more positive than negative in order to combine in order to end up with a positive 7 in the middle. Okay, so with what we already wrote in number 3, 1, 2, 5, 3, right? I know my outer need to be a negative 3. So like I said earlier, when we factor in trinomial, the first term is always positive, right? So the sign go on the back number on the second terms. So that means to get the negative 3, it gotta be positive 1 times negative 3. So for outer, inner got to be positive what? 10. Positive 2 times 5. All right, since the first term is 5x squared, so that got to come from 1x times 5x. So I put my variable behind the 1 and the 5, and I am done. My answer, x plus 2 times 5x minus 3. Okay, so this is one way that we can factor trinomial called trial by error. Well, what do you mean by trial? Well, trial is if the number we put in the parentheses does not give me does not allow me to end up with the +7 in the middle from the inner and outer, then I can swap the two backside number. Okay, and try it again. If that doesn't work, then we have to use a different sets of factors, okay, until we can get it right. Okay, another method is called the AC method. The A and the C are referring to the coefficients of the trinomial form, A times C method. It doesn't always work. AC method does not always work because when students do the trial and error method long enough, you can just kind of look at these numbers and you can basically figure it out quickly, where, what number goes where and what are the signs. All right, let's try again, okay? Okay, there's no greatest common factor between these three terms, so I'm gonna copy and paste this real quick. Maybe it makes it a little bit easier. Put it right here also. Okay, so for number 3, 2 parentheses right away. All right, find all the factor of the first term and find all the factor of the second term. So that's number 1 and 2. 20. What times what is 20? Well, I know 1 times 20 is 20. 2 can go into 20 10 times. 3 cannot go into 20. 4 can go into 20 5 times. After 4, I try 5, but I already wrote it down, so that should be the end of it. 24. Start with 1. 1 times 24. 2 can go into 24 12 times. 3 can go into 24 8 times. After 3, we try 4, go into 24 6 times. 5 cannot go into 24. Then the next one is 6, which I already have. So that should be the end of it. Okay, so number 3, the factor of the first term, 20, should go at the beginning of the two parentheses. The factor of the last term, 24, should go on the back side of the two parentheses. There you go. Now, without doing the inner and the outer, these numbers here is not going to work out for me to get my middle term, because when I put 4 in the front and then put another 4 right behind it, these two 4s in the same parenthesis will actually give me a greatest common factor of 4 that I can factor out. But we already said at the beginning there are no greatest common factor between, for this trinomial. So you cannot put numbers in the parenthesis where it's gonna give you a greatest common factor that you don't have. So naturally, this is not gonna work without even trying the inner and outer. So when this doesn't work, we will swap the two backside number. Put a 6 with the 4, 4 with the 5. But when I put the 6 with the 4, that also give me a greatest common factor of 2 that I can factor out. So that's not going to work. So that means 6 and 4 doesn't work for me. Okay, so this is where the trial and error comes in. Okay, so how do I know 4 and 6 doesn't work instead of 4 and 5 doesn't work? Because if I would keep the 4 and 6 on the back, then use the 2 and 10 in the front. 2 and 10 along with 4 and 6 will constantly give me greatest common factor that I don't have. So that's why I'm choosing 3 and 8. So I'm definitely not going to put the 8 with the 4 because that give me another greatest common factor of 4. So I'm going to put 3 with the 4, 8 with the 5. Okay, so without even doing the math in your head about in and outer, you can just look at these numbers and you know who should go with who and who shouldn't. Okay, so now let's do the sign. Well, let's figure out if we can get to the middle term first. So my outer, the two outside number multiplied together. 4 times 8 is 32. Inner, 3 times 5 is 15. Can 32 and 15 combine somehow give me 47 in the middle? Yes, it can if I add. So when the last sign is positive, the in and outer got to add to get to the middle term, 47. When the last term is positive, the two signs in the parenthesis will be plus plus or minus minus. So it all depends on the middle term. If the middle term is a negative, then both in and outer got to be negative. So if you can recall, I said this many times before, terms with the same sign we will add. Terms with different sign we subtract. There you go. Last sign is negative. That means the inner outer got to subtract to get to the 7 in the middle. And that's how some students can do this just by looking at it, because they know ahead of time whether they should add or subtract the in and outer to get the middle term. Therefore, that help them to figure out what factor to use. Okay. All right, so now I know both of these in and outer got to be negative. So I'm going to write down my number 3 again. 4 and 3, 5 and 8. Both of them got to be negative. And since my first term is b squared, right? Then b times b is b squared. So I will put the b behind the 4 and the 5 because that came from the first term. There you go. 4b minus 3 times 5b minus 8. Okay, so we will do this a lot throughout the semester, factoring trinomial. Another type of factoring problem I want to introduce is factoring the difference of squares. Okay, so we talk about difference of square back in topic number 4. Okay, how to recognize the difference of square problem. So now we're just looking at it backwards. The reason why these type of problems is called difference of square, difference is means subtraction of two perfectly square terms. Okay, so how do you recognize difference of square? You always got to know, you're always going to see two perfect square terms, and there's a subtraction sign between the two perfect square terms. Or in other words, the two perfect square terms have an opposite sign. That's another way of identifying it. Another easier way, and another good way to identify is know your perfect square numbers. So perfect square number, let's write a few of them down to kind of help us spot. The hardest one to spot is 1 squared, which is 1. 1 is always perfectly squared. 2 squared, 3 squared, 4 squared, 5 squared. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So these are all perfectly square number. 6, 7, 8, 9, 10. 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. 10 squared is 100. 11, 12, 13. I'm just writing down some of the popular ones, okay? 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. We're switching the 6 and 9. 15 squared is 225. Okay? So when you see these perfectly square number, that's give you a hint. All right, factor the polynomial completely. So x squared minus 16. So how do I know this is a difference of squares? I see two perfectly square terms with a subtraction sign in the middle. So my answer, a squared minus b squared should equal to a plus b times a minus b. So if I follow the formula, okay, a squared is already squared, just like my x is already squared. So what was x squared? What was this x squared before it was squared? Well, it got to just be x. So before x squared was squared, it got to just be x. What was 16 before it was squared? It got to be what? It got to be 4. 4 squared is 16. So b is 4. 1 plus 1 minus. There you go. Your answer, x plus 4 times x minus 4. That's all it is. All right, consider the following polynomial in your own word. Which type, so this is your first discussion, which type of factoring problem is this one and why? Okay, so this does look like what? It does look like a difference of squares, right? 9x squared, 16 is also perfectly squared. Okay. So basically what I'm writing up here is basically power rule. Okay, so some of the exponent rule that we learned in other topic is being used. I'm just don't write it out like that. Okay, so this is actually a difference of squares. And the reason why, because you do see what? Two perfect square terms, and there's a subtraction sign between the two perfect square terms, okay? All right, factoring this polynomial completely. So right now, the 20 and the 45 are not perfectly squared, okay? So at the moment, this is not a difference of square. So like I mentioned before, every factoring problem, the first thing you do is factor out the greatest common factor. So between 20 and 45, I can factor out a 5. No variable can be factored out because they are not repeating between the two terms. The second term doesn't have x in it. The first term does not have y in them, so can't factor any variable. Just a 5. 5 going to 24 times, didn't factor any variable, so x squared is left, minus 4 going to 45 9 times, y squared should stay the same. So at the beginning of this video, I said the way how we check for the answers is check inside the parenthesis to see if anything can be a factor. So you have to recognize that this is a difference of squares inside the parenthesis, because you see two perfectly square terms with a subtraction sign in the middle, so this can be factored again. Okay, keep my 5. So a squared, right? This is already 4x squared is already squared. So what's my a? That's what I'm asking. What's my a? What's my b? Okay, but because this is already squared. So what was 4x squared before it was ever squared? What was in here? It got to be what? Before 4 was squared, it must be a 2. Before x squared is squared, it got to be 2x. It got to be x. Because 2x whole thing squared will be 4x squared. So that means my a is 2x. My b before 9 was squared was a 3. Before y squared, before y was squared, it must be y. So b is 3y. 1 plus 1 minus. There you go. That's the answer. Okay, 5 times 2x plus 3y times 2x minus 3y. So in your own word, what should be the first step when factoring polynomials? It should always be what? Factoring out the looking for the greatest common factor. All right, let's try this following example. This example has a lot of different things embedded in here. Okay, so like a summary of the ones that we already done. So the problem here tells you, the steps tell you factor the greatest common factor. So every term does have an x. So I can factor out x. So if I factor out the smallest exponent is first power, that's all I can factor out. So take 1x from 4 of them, 3 are left. Take 1 from 3 of them, 2 is left. Take 1 away from 2 of them, negative 4x is left. Take the only x to the outside, the last term is positive 4. So if you look inside the parenthesis, this is a factoring by grouping problem. So I'm going to underline the first two, underline the last two terms. This x stays. This big parenthesis is still there. Inside the parenthesis, factor out the greatest common factor of the first two terms, which is x squared, right? Smallest exponent is x squared. So let's see what's left. Remember, I'm doing division. I'm taking x squared, go into x to the third, and go into negative x squared. So this is basically, I'm basically doing a quotient rule on the exponent. Take 2 x's away from 3 of them, 1 x are left, right? If you subtract the exponents. Okay. X squared going to x squared is, x squared going to negative x squared is negative 1 time. Right? It's negative 1 time. So I'm doing division without writing it out as a division. All right, between the last two terms, remember the two parentheses got to match. Between the last two terms, I have to factor out negative 4, because negative 4 going to negative 4x is positive x times. Negative 4 going to positive 4 is negative 1 time. Have to factor out negative 4 in order for the two parentheses to match. Because once they match, that becomes my greatest common factor. So this x, original greatest common factor x, still up front. Now I'm gonna factor out the x minus 1, and I'm dropping the big parenthesis. So what's left? Factor out the x squared minus 1 to the outside. X squared is left for the first term. All right, second term, what should be left? Should be a -4. Now, if I look inside the parenthesis again, that is another difference of squares, because 4 is already squared. So x times x minus 1 still there. So difference of squares should give me 2 more parentheses. Before this x squared was ever squared, it was x and x. Before this 4 was ever squared, it was 2 and 2, 1 positive, 1 negative. So here's my answer. X times x minus 1 times x plus 2 times x minus 2. All right. So the homework here, question number 1 and 2 are on the handwritten portion. So on the computer portion, when you run into this particular homework problem, you're gonna see this instruction. Okay, there are very standard instruction. It tells you exactly what you need to do. Question number 1 is on topic 5 homework handwritten portion. Please download the handwritten portion and write the answers. And handwrite the answers. It's got to be handwritten for your homework. Once you have completed both computer portion and the handwritten portion of the homework, please submit the computer portion and then upload the handwritten portion. Okay, remember both portion will be graded at the same time. If the handwritten portion is not uploaded after the computer portion is graded, then all the handwritten portion will be counted as incorrect. Okay, so once again, I do not want to open up your computer portion and then looking for the handwritten portion is not there. And the reason why I open your computer portion because the grades for the handwritten portion got to be entered inside the computer portion for the grade, for your grades to kick in. So I gotta have both portion in front of me when I do this grading. So once again, if you're not ready to submit both portions, just finish both portions, then submit both at the same time. Okay? Or submit both of them back to back. Don't don't just submit the computer portion and wait 2 weeks later, then upload the handwritten portion. That's not gonna work because I already graded. Okay. I can't just keep on waiting for students, for hundreds of students to upload their handwritten portion throughout the entire semester. That's just not gonna work. That's not gonna work for me. It's too many to keep track. All right. So inside the box below this instruction for the computer portion, please simply just copy and paste this phrase I have read, and it will follow the above instruction inside the box below. So again, question 1 is on the handwritten portion, right? So in the computer portion, you just enter this. So make sure you just follow what we did earlier, okay? Find all the factors, the first term, last term. This particular example, question number 4, it stops at step number 4, which is simply demonstrate the inner and outer combined, like I have shown up here. Okay, it stops right here. Okay, because once you wrote out what's in the parenthesis and then tell me what the inner and outer is and do the signs, then you're pretty much good to go. Okay. So make sure you demonstrate the inner and outer combined the same way as I did in the lecture video. Question number 2 is your factoring by grouping. Make sure you group the first two and the last two by underlying them. Okay, by underlying them. All right. So thank you so much for reviewing topic number 5 on factoring polynomial with me. Okay. Thank you for watching.